Last time we worked on the 71 Firebird, we put a 600 horsepower 468 in and a TKO 600 transmission. We did some detailing on it, and to be honest, the car drove great. As great as a stock sort of suspension muscle car can drive. But now we've put a BMR Torque Arm suspension in the rear so that we can really hit the gas hard, not worry about wheel hop, and hit some corners really hard. Installing a BMR Torque Arm is actually pretty straightforward. For the most part, everything bolts into existing locations on the car. First thing you need to do is remove the rear body mounts from the subframe and install the brackets for the torque arm crossmember. In the case of our 71 Firebird, we already had some subframe connectors installed in the car, which made installing the torque arm crossmember a little more difficult. We decided it was best to loosen all the front subframe bolts and put a jack under the front of the subframe and then gently pry the subframe and subframe connector away from the body to get enough room to remove the stock size body mount bushing and replace it with the thinner body mount bushing and the bracket. After you've installed the brackets to the subframe mounts, you simply bolt the crossmember in where the torque arm will later attach. Moving to the back of the car, installing the torque arm mainly requires unbolting a lot of the original suspension components. The first thing we did was remove the stock sway bar that was on the back of the car for a couple reasons. One, we're not going to use it anymore, and two, it was in the way of adding the new girdle cover for the differential and also the bracket for the torque arm's cage. Installing the bracket for the torque arm cage is pretty straightforward. Once you've cleaned all the old gasket material off of the differential housing, it simply bolts up in between the new girdle cover and the differential housing itself. Once we've installed the bracket for the torque arm's cage and the new girdle cover, we can turn our attention to the stock suspension. First thing we need to do is remove the leaf springs. And we decided it would be easiest to do one side at a time so we didn't have to remove the rear axle from the car. We could support it with a jack and the other leaf spring. With the driver's side leaf spring out of the way, you can install the new lower control arm bracket and lower control arm into the original spring perch. Once you've installed the driver's side control arm, you move to the passenger side and repeat the procedure. Installing the crossmember is the most difficult part of the process. Now, BMR gives you some reinforcing plates and some crush sleeves where you can actually bolt the crossmember in. But we decided that welding it in with our HTP MIG 200 welder would be a stronger and more reliable way to go since this car is pushing over 600 horsepower. Before you commit to welding the crossmember in, you want to make sure it's square in the car. Because if it's not square, you're going to have some strange suspension geometry, and the car may behave differently when you hit a bump on one side versus the other. Measuring if something's square under a car is pretty straightforward. A lot of times there's guide holes somewhere in the car, and on an F-body, they're near the spring perches, which is what GM used when they welded these cars together originally. You simply measure diagonally from this guide hole to a point on your crossmember, and then you compare that measurement to the other side. If those two measurements are within an eighth, it's considered to be square enough to weld in. Once you're sure you've got everything in the right spot, it's important to properly prep your surfaces before you weld them. We made sure to grind the undercoating off and apply HTP's weld-through primer to the surfaces to ensure that we didn't have any rust creepage from behind our new component. Now that we've got the crossmember welded in, the rest of the install is very straightforward. You simply need to assemble and install the shocks, assemble and install the Watts link, and bolt the cage and the torque arm to the differential housing. You might be asking why we're putting a BMR torque arm in the back of the 71 Firebird. And the reason is that in a leaf spring car, you can get what's called spring wrap, and that can end up with wheel hop, and the car may not be real controllable if you get tire spin. And a torque arm is something that eliminates wheel hop. And it's actually very similar to something GM did on third generation F-bodies, that there's this long arm that goes from the rear axle up somewhere in the front of the car. On the third generation cars, it actually went to the transmission housing. In this case, we put a crossmember in up here. And what this arm does is it prevents the pinion from trying to climb when you step on the gas really hard, or in the other instance, if you downshift and use engine braking, it prevents the pinion from trying to dig down, which can also cause spring wrap in some strange racing circumstances. The other cool thing about the BMR torque arm suspension is it includes a Watts link. And a Watts link does the same job as a panhard bar, but it does a better job in some ways. With a traditional panhard bar, the panhard bar is attached somewhere to the axle on one side of the car and somewhere to the frame or the body on the other side of the car. And what happens is when you hit a bump, that parallelogram that's formed by those 2 points causes the axle to shift side to side a little bit. When a panhard bar is properly set up, that amount is very minimal, but it's still there. So if you're really throwing a car into a corner real hard and then you hit a bump, you may get a weird reaction to the back. The Watts link eliminates that because it has 2 points on the frame and 2 points on the axle with a pivot in the middle. So anytime the axle moves up and down, that link twists. This keeps the axle centered in the car at all times. The other thing that a Watts link does that a painted bar doesn't is it does some of the job of a sway bar. Because of where the pivot is mounted on the axle, you can adjust to a point where the car's roll center is, which means where the body rolls in relation to the axle. But you gotta be careful here. If you have it adjusted wrong, the car may roll too much and you'll have some weird handling there, which is why there's several sets of holes where we can move this link up and down after we've driven the car to see how it reacts. The way the Watts link does the same sort of job as a sway bar is that if the axle rolls, this pivot point is in the center of the axle's gravity. And if it tries to roll too much on one side, this pivot point tries to move up or down and has to try and move these arms, which it can't move to the sides. It can only move them up and down. And that's where you get the slight effect of a sway bar. That's not to say that it does everything a sway bar would do, though. We decided that while we were improving the handling characteristics of the 71 Firebird, that we also needed to improve the brakes, because there's nothing worse than having a car that can take the corners really well, but you can't come up to the corner fast enough. We decided to go with a Baer 6-piston brake kit, which is a bolt-on kit specifically designed for the 71 Firebird. Installing the Baer 6-piston brake kit is no different than any other bolt-on kit. As with most GM vehicles, you have to remove the C-clips and the axle shafts, remove your old backing plates, and install the new integrated parking brake backing plates. Install your caliper and your rotor and rebend your brake lines. The last thing we did under the 71 Firebird was replace the old American racing wheels with some new BOZE forged 17-inch wheels. There are a couple of reasons we did this. One, 6-piston brakes obviously are pretty big, and we needed a wheel that would fit over them. And two, what's the fun of having 6-piston brakes if you can't see them? So what we're out here doing today is we're breaking the Baer 6-piston brakes in, and we're tuning the shocks. The front already had QA1 coilovers, but they were set on their softest setting to kind of fit in with the leaf springs and the stock shocks in the back. But now that we have the RideTech coilovers with the BMR torque arm, we can adjust the rates. So we've turned the front shocks up and we've turned the back shocks down a little bit, and we've got this thing to corner really fast and really flat. Honestly, before we did any of these suspension modifications to the 71 Firebird, it was one of the best driving cars we've had through this shop. But it was still basically a stock 71 Firebird, and there was plenty of room for improvement. Installing the torque arm and some stickier tires really improved the acceleration of this car. Because as much fun as it was with 600 horsepower and a regular street tire, it was basically tire smoke if you looked at the gas pedal wrong. With the torque arm suspension and the new tires, when you accelerate with the 71 Firebird, you really get all the power to the ground. And then when you come up to the corners, this thing sticks like glue. This car corners so fast and so flat that when you turn in, you got to be careful not to turn in too quickly. And if you do turn in too quickly, it's very controllable. You actually end up with just a little bit understeer. But if you're leaning on it hard going through the corner, the tires stick so well, you'd really have to mash the gas pedal before you had any hint of tires breaking loose and oversteer. We really enjoy working on the 71 Firebird because it's always a partial project. The owner has had this car a long time and really likes his car, and every time we work on it, it's just to do some minor improvements to it. And the improvements we've done in the last year have transformed this car from just a good-looking car to a very good performing car. If you want to learn more about the 71 Firebird build or about us doing upgrades to your own car, contact us at V8TVshow.com.